All right. Let me know
Yeah, you're
when
you're
we're
good
good
to
to
go.
go here. All right. Cool. Well, first of all, thank you so much, Dom, for making this happen. Finally, I just wanted to shout out Reactadelphia and all the people who put this event on. It's awesome that we have events like this, so we can have great developer content in these times. I was supposed to come to Philadelphia for this event. It would have been my first time in Philadelphia, so we're gonna have to run that back after the world is in a better place. But nevertheless, I'm so stoked to be here. Like Dom said, my name's Trevor Blades, and I'm a web developer. I work at Apollo, and Apollo, if you're not aware, we're a company that creates tools for developers just like you and I to use GraphQL in our web apps and websites. Um, so the today I'm going to be talking to you about the story behind our multi-language code blocks in our documentation. And the title of my talk is Code Block Alchemy, because the technique that we use to achieve this effect has a little sprinkle of magic in it, and I think that you'll be really interested by its origin story. So I work on the developer experience team at Apollo. One of my main areas of focus is our documentation site and the infrastructure that runs behind it. And as a team, we're heavily invested in creating awesome documentation experiences for our developers. And there's a few things that I know about documentation and our developers, and so I'm gonna touch on a couple right now. The first thing is that code samples in documentation are really important. Code samples allow us to convey complicated ideas to developers in a really concise format. So you can imagine that explaining how to get set up with Apollo using only paragraphs of text would be really, really cumbersome and difficult for developers to understand. And that's not what we do. We rely on code blocks pretty heavily. Code blocks allow developers to understand what working code should look like. And in many cases, they enable developers to just copy and paste groups of code and use them in their apps and get a sense for how to build with these tools right away. It's really good, and it lowers the barrier to entry to some of these tools. Code blocks are also typically written using the tools and the languages that developers are already using in their apps. And speaking of the tools and languages that developers are using in their apps, the other thing that I know is that TypeScript is becoming really popular. This is a chart that I took out of the State of JavaScript survey from last year, which shows that over half of the web developers that took the survey use TypeScript or have used TypeScript and continue to use it in their apps. And almost everybody interviewed has at least heard of or tried TypeScript before. This is pretty compelling. It tells me that developers are using TypeScript, and back to my previous point, developers want to see their code samples written in languages that they're using currently. Last year, our code samples did not use TypeScript. They looked great, they worked just fine. However, they were just using JavaScript. So this presented us with a challenge. We wanted to demonstrate to developers how to use Apollo with TypeScript. However, we didn't want to alienate JavaScript developers, and we need to keep those existing JavaScript examples around. We also don't want to write the same thing twice. This would introduce a gigantic maintenance burden if every time we wanted to author a code sample, we'd have to write two code blocks. You can imagine if we had to then update a code sample, we have to update it twice. That's not ideal. So just touching on that third point for a moment, how can we avoid writing the same thing twice when it comes to code samples? Well, there's a few things that I knew. The first is that TypeScript compiles to JavaScript. That might be useful. The second is that our code samples in our docs are written using Markdown. And we use Remark, a Markdown processor, to process that Markdown and eventually turn it into HTML. And I've used Remark a little bit in the past, and I knew that Remark plugins give us the ability to read the content and change it in some way using code that would normally run in Node.js. And the last thing that I knew that might be relevant is that the TypeScript compiler runs in Node.js. So I think you might see where I'm going with this. But first, I want to touch on Remark plugins. The way that Remark plugins work is they allow you to visit nodes in your Markdown abstract syntax tree by some characteristic. And in our case, that might mean the node's tag name. So when we're talking about code blocks, we're usually talking about pre-tags. So we could say visit every pre-tag, and then as number 2 here says, perform some work. Like I mentioned in my previous slide, this means really anything that you could normally run in Node.js. And then they allow you to synchronously mutate your Markdown AST and affect the eventual shape of it. So with all of this in mind, I had a plan. We would write all of our code samples in TypeScript, then using a Remark plugin, compile that TypeScript to JavaScript with the TypeScript compiler. The Remark plugin could then insert those new code samples back into the page, and we would write a React component that would allow us to toggle between the two languages. Let's see how this plan works in practice. So here's a really, really simple TypeScript example. We're importing some parts of the Apollo client package and instantiating a new Apollo client in TypeScript. When we run this code sample through the TypeScript compiler, we get this. And at first glance, this is pretty good. It certainly looks like JavaScript, and I think it would more or less satisfy our use case. But I notice a few things right off the bat. The first is that these double quotes in our TypeScript import statement get turned into single quotes in the JavaScript example. But these double quotes remain as double quotes in the JavaScript output. That's kind of weird. Not a total deal breaker, but something that just caught my eye. And the other thing is that these spaces, 2-space indentation gets turned into 4 spaces of indentation. Again, that's not too crazy, but it's inconsistent. And the last thing that I'll point out is that this empty space between our block of import statement and the client declaration here gets just removed in the TypeScript example. So those are a few things that I noticed, but overall, it's not that bad. But let's see what happens if we feed the TypeScript compiler a more complicated example. Okay, take this one for instance. You're gonna have to excuse the small font size here. I assure you that the actual content of the specific code is not super relevant here. But this is a TypeScript example showing how to use the Apollo client use query hook in a React component. Now, when we run this code block through the TypeScript compiler, we get something that looks like this. And wow, that is way different. So a few things jump out at me, and I'll point them out, just like I did previously. We have some the same indentation change going on here, and this nested ternary operator just gets one-lined in the output of JavaScript, and that's not really viable for somebody reading documentation. You're not gonna encounter that and really be happy horizontally scrolling across to read the whole thing. And the last thing that I noticed is that, once again, our empty lines separating this group of if statements and the return statement are just removed in the output of JavaScript. In addition, the JavaScript example introduces some new line breaks. So these if statements that were one-lined in the original code get split onto multiple lines over here. So the problematic one of all of this, though, in my opinion, is this the missing empty line in our JavaScript output. And when we're authoring code blocks, we like to use empty lines as a means to separate different thoughts, not unlike how an author might use paragraphs to separate ideas in their writing. So this getting removed is problematic for us. It changes the original intent of the code block author. What this points to is that the TypeScript compiler, it doesn't care about our formatting or our white space. On one hand, it is JavaScript, so at least that part is right. But the empty lines being removed, and the spaces getting converted to tabs, and the new line breaks being introduced, these are all kind of deal breakers for us. And while this is disappointing, I can't say I'm all that surprised, because after all, we're talking about the TypeScript compiler. I'm going to talk about a compiler for a moment. So a compiler is a program that takes some source code written in one language, and it outputs code written in another language. Generally, when we talk about compilers, we're talking about programs that output code that's ready to run on a machine and not be read by a human. And this is true of the TypeScript compiler or the C compiler, if you're familiar with that. But there's another type of program out there with a similar name. It's called a transpiler. A transpiler is a special class of compiler, also known as a source-to-source compiler, where the input is still source code of one language, and the output is code in a different language, but typically that output code is made understandable by a human. Or if you Google this, it'll tell you that the code is written in a similar level of abstraction as the source. A lot of the time, the output from a transpiler still needs to go through a compiler before it can actually be run. And when we think about transpilers, or when I think about transpilers, one name jumps to mind immediately, and that's Babel. And if you've worked with React before, you might be familiar with this program. Babel is a transpiler that we use to turn next-generation JavaScript into JavaScript that can be run by most browsers. But did you know that Babel can also transpile TypeScript using the Babel preset TypeScript library? That's a pretty handy thing to know for our purposes here. And a couple other things about Babel. It doesn't care about your formatting. It doesn't have any opinions on that. It's not its purpose. And in fact, you can pass a specific option to the Babel's transform function called retain lines that forces Babel to keep around empty lines that might get removed in the transpilation. So this is really useful for our purposes as well. It might be promising. So let's see what happens if we run the exact same code sample that we just compiled a few moments ago through Babel now. On the left, we can see the TypeScript input, and on the right, the output that we get from Babel. Already, this is looking more readable than the TypeScript JavaScript, the TypeScript compiler's output that we saw a few slides ago. But there's still a few weird things going on there, and I'm going to point a few out. The first thing that jumps to me is this set of empty lines at the top of the file. That's kind of weird. This line's indentation gets kind of janky, and all of the content within our render statement also kind of has some weird indentation stuff going on. But the real promising part of all of this is that the space that was created in the original example that separates our group of if statements from a return statement is left intact. And that's awesome. That means that the original intended phrasing of this code sample is still around. And that's what we're going for here. So we're almost there. Like I said, we retain the same phrasing in whitespace as the original TypeScript example, but there's some empty space kicking around, and there's incorrect indentation, janky formatting, still leaves lots to be desired. But if only there were a way that this code could be made a little prettier. So Prettier is another program that some people here might be familiar with. It's called a code formatter, and it cares about things like spacing and indentation and line length. It takes some code as input and returns more nicely formatted code. And for what we're doing, this is important. We want our code in our docs to be nicely formatted. So the code block that you're seeing on the right is what happens when we pass that Babel output directly into Prettier with the default settings. And it already looks great. This is something that we could use right away. So with that, I devised a new plan. We're still going to write all of our code samples in TypeScript. But rather than compiling the code samples using the TypeScript compiler, we're going to transpile them using Babel. Then we take that Babel output and run it through Prettier to fix up the formatting. And then using our Remark plugin, we'll insert that code back into the page and finally create a React component that allows us to toggle between the two languages. So next, I want to talk about inserting the code block back into the page. I'm not going to dive too deep into the exact implementation of our Remark plugin here, but I just want to touch on the general concept. Like I said at the beginning of my talk, Remark plugins allow you to visit nodes in a Markdown AST. And for our purposes, what we could do is say visit all code blocks that are written in TypeScript, do all of our transpilation and formatting, and then insert that output immediately after the code block that we're currently visiting. And that's what we're doing here, and it actually works. And it's pretty cool. However, not every TypeScript code block in our documentation should be transpiled. And we need to have some form of control over which code blocks we transpile and which ones we leave alone. And there's a few different ways that we can go about doing this. But the method that I chose to go with for this task was using a wrapper component in the Markdown. So in Markdown, you can use HTML and render, bits of Markdown within it by leaving spaces or empty lines between your opening and closing HTML tags and the Markdown in question. So it means that our markdown file would look something like this now. TypeScript code blocks that we want to be transpiled simply get wrapped in a div tag, and the ones that don't, or the ones that we don't want to be transpiled, can be left alone and nothing happens. We have to change the logic behind our Remark plugin a little bit to allow for this. So rather than saying we want to visit every code block that is written in TypeScript and transpile it, we would say something like, we want to visit every TypeScript code block whose previous node is an opening div tag and whose next node is a closing div tag, and then transpile those. But everything else can be ignored. And this strategy actually works. The code blocks that we want to be transpiled get transpiled, and the ones that we don't get left alone. So I realize that this is a React event, and I haven't talked very much at all about React yet. So why don't I get into the next part of the plan, which is toggling between TypeScript and JavaScript. And to achieve this, I wrote a pretty simple React component, small enough to fit on this slide. I hope the font size is okay for everybody, but I'll walk through it step by step. So I call the component a multi-code block. And this multi-code block uses React state to keep track of the index of the child that it wants to show. So the idea is that this component should only show one child at a time. And the children that get passed to this component are just our two code blocks, our TypeScript code block and our JavaScript code block. So to control that index, I'm using a select input, and I can map through each of the children that get passed to the component, creating a select option for each. And when the select input changes, we just call setIndex with the index of the selected child. And then finally, we render the child at the specified index at the end of the component. So this is cool. It should do the trick. But now there's a new challenge. How do we actually use a React component within our Markdown file? And for this, there's a tool that I really, really like using, and it's called MDX. And it allows us to do just this. MDX allows us to import React components and then write JSX within a Markdown file. So our previous code block example, where we're wrapping the TypeScript code block with a div tag, gets changed slightly. Instead of a div, we're going to use our new MultiCodeBlock tag. And what this means is we're also going to need to change the behavior of our Remark plugin. Rather than looking for code blocks whose previous and next nodes are opening and closing div tags, respectively, we're going to look for code blocks that have whose previous node is an opening multi-code-block tag and whose next node is a closing multi-code-block tag. And this approach works for us. In fact, this entire slide deck is written using MDX. So I was able to take this multi-code-block component that I just showed in the previous slide, and I'm using that here in this output. When I select my JS option from the select, the content of the code block changes, just how I was hoping. So that's really exciting. And this solution works really well for this one code block. But then what happens when we have multiple code blocks on a page? You can imagine having a tutorial article with 5 or 6 code blocks and going through, unhappy with the default value. It would be a pain in the butt to have to go and change the selected language every time you come in contact with a code block. And if one of the goals of the developer experience team is to create an awesome documentation experience, then unfortunately, we've failed. That's not an awesome documentation experience. In fact, it sounds really cumbersome. So to fix that, we need to make sure that all of the code blocks on a page remain in sync with each other. Luckily, React has just the tool. React context can allow us to do this, and we just need to make some minor adjustments to our code, both on the Markdown side and the multi-code-block component. But I'm going to talk about those changes right now. So we create our code block context using the React create context function, and we're going to export a new component called the code block provider. It takes the use state hook straight out of the previous multi-code block component and implements it within itself, and then passes that state value, which is just a tuple of the state variable and a setter, as the value to the code block context provider. And then all of the children that exist within that provider can get that state via context. What that means is that our multi-code block needs to undergo a minor change. Rather than using local state, we're going to take advantage of the use context hook and just pass in the code block context as its only argument. And then we can continue using index and set index just like we were before, and everything works. And I'm going to demo that now. So this is what our MDX file will look like now. We still have our TypeScript code block, and it's wrapped by a multi-code block component, opening and closing tag. In fact, now we have two. We have two multi-code blocks back to back, and then all of those are wrapped in a code block provider, the component that we just created on the previous slide. And this is what the output looks like. When we go and select a different language in one code block, both get their language updated. And we can do that in any code block on the page, and we get the same result. And that is exactly the experience that we're after here. So to recap, to accomplish this, I used a Remark plugin to read our Markdown AST and make edits to it. We use Babel to transpile TypeScript code and then run that outputted JavaScript through Prettier to fix all the formatting issues that might occur. Finally, I'm using MDX to take advantage of my multi-code block React component within a Markdown document. And that's pretty awesome. So to reiterate, on the developer experience team, our goal is to create an awesome documentation experience. And if one of the hallmarks of an awesome documentation experience is code blocks that are written using tools and languages that developers are already using in their apps, then I think that we've accomplished that using this technique. And that's all I've got. I've left a few links at the end of my slides here. You can view all my slides if you go to alchemy.trevorblades.com. And I'm going to just touch on a few of them here. So the first thing you might want to see is the real-life implementation of multi-code blocks in our docs. You can check that out if you visit apollographql.com/docs and check out our full stack tutorial. You can also check out all the source code for the Remark plugin that was the culmination of all of this effort, and that's on my GitHub. It's a package called Remark TypeScript, and you can feel free to use it in your own project if you like. I also want to shout out this awesome Stack Overflow answer that describes really well the differences between a compiler and a transpiler. So if that's something that's interesting to you, I suggest you check that out. And then for anything else, if you have any questions for me, or you just want to get in touch and shoot me a line, I'm on Twitter at TrevorBlades, so feel free to hit me up. But that's all I got. And I want to thank everybody so much for listening. I hope this was interesting. And just want to say, stay safe and keep your spirits high. And thanks again, Reactadelphia, for putting this event on. Oh yeah, let's do it. No, so in my example here, what I've done is effectively wrapped an entire page of Markdown in a code block provider. So that's one option. In practice, you might have paragraphs of text in between these multi-code blocks, but you only need one provider per page. In fact, what we're doing in the Apollo docs is we have like a page layout where we implement the multi-code or the code block provider at the page layout level. And so every article that we write, we don't need to import and implement the code block provider. We can rely on it being there all the time. And then the last thing I'll say on that subject is that in the Apollo docs, we also save the user's language preference in local storage. So the selection that they make on one page actually persists across all pages too. So that's another little wrinkle that I didn't want to get into, in the flow of the talk. But yeah, that's sort of the way that works.
Sweet.
I hope that helps.
So I'm gonna ask that. So that was an answer to a question earlier. I was muted for the stream, but not for the Skype. So I'm just gonna re-ask that question for the YouTube video. Where the heck did it go? So that question was, does each component need to be wrapped in the provider since the rest of the page is in Markdown? And phenomenal answer. And then we had one more. What is the font at the title and at the end?
Excellent question. So the title and the end fonts, it's a font called Lifecraft. It's like a fan-made font that's supposed to emulate the World of Warcraft.
Yeah, it's rad.
But this like embossed and golden look, I had to do some custom Photoshop,
some wizardry.
But I can tell you exactly how that happened. It was really easy. You just load your font up in Photoshop, type your message, and then using the bevel and emboss effect, you just turn that sucker up all the way, and it gives you that nice like embossed look. And then change the font color to yellow, and Bob's your uncle.
You're a freaking embossed look, dude. I appreciate you so much for coming out. This talk was awesome. I'm going to be forced into using TypeScript. I know it's coming soon, so just be ready for me to be sliding up in them DMs like I always do.
Please do, yeah.
All right, man. Thank you so much.
All right. Thanks, John.